So again, good morning. Today we are going to be solving equations algebraically. Specifically, we are going to be looking at solving quadratic equations algebraically. Okay? So just a quick refresher as to what a quadratic equation is. A quadratic is equation one that's in the form ax squared plus bx plus c. And it's kind of weird. This morning, my 8th grader comes up to me, Dad, what's a quadratic equation? I'm like, we're talking about it today in the pre-calc. So, yeah. So a, b, and c are real numbers, and a is not equal to 0, because if a is equal to 0, then that part gets covered up, and now you just got a linear term, or that x squared term gets eliminated, and so you just have a linear equation. Many ways to solve quadratic equations. Yesterday, you saw graphing, the two different Desmos and TI-Nspire graphs. Today, we are going to be factoring, completing the square, and using the quadratic formula. Okay? So that we can get answers, either real numbers, rational or irrational, or imaginary numbers, numbers with I. So, one quick thing, because it's a quadratic, and the biggest exponent, we call that the degree. Remember, the degree of this is 2. I need to have 2 answers. Okay? Need to have 2 answers when we're done with that particular problem. Okay? So, example number 1, we want to solve by factoring. So, that is, for lack of a better term, what we're going to do is we're going to do parentheses. Okay? You might hear us refer to them as the butt cheek method, because the parentheses look like a pair of butt cheeks. Okay? So we're looking for these two numbers here are going to multiply together to be 4x squared. And then these two numbers here are going to multiply together to be 3. Well, there's only one pair that can multiply together to be 3. So I'm going to start there with 1 and 3. Okay? And then I got to kind of try different numbers. So let's try, let me go back to the green. Let's try 2x and 2x. Okay? Or I could try 4x and x. But then in my brain, I'm saying to myself, this number times this number is 6x. And this number times this number is 2x. Together, those make 8x. That's what I need. So I need to have negative signs in between them. Okay? Guess and check is you just gotta kind of try stuff. You'll see patterns every once in a while, and the more you do it, the easier it becomes. Okay? So this really then is, now let me get rid of all of this writing, 2x minus 1 and 2x minus 3 equaling 0. Once I have it in factored form, then I can take that and I can divide that up, and I can say 2x minus 1 equals 0. And 2x minus 3 equals 0. And then I can solve those equations. And so I can go add 1 to both sides, gets me 2x equals 1. Divide by 2x equals 1/2. Add 3 to both sides, 2x equals 3. Divide by 2x equals 3/2. Okay? And then I can go back and I can check them. 1/2 squared is 1/4. 1/4 times 4 is 1. 8 times 1/2 is 4. 1 minus 4 is negative 3, plus 3 is 0. That one checks out. 3/2 squared is 9/4. 9/4 times 4 is 9. 8 times 3 halves is 12. 9 minus 12 plus 3 is 0. So my two answers here are 1/2. And whoa, I don't know why it switched back over to green. That was kind of funky. And 3/2. Always good to check your answers back at the end. Okay. Questions, comments, concerns, clarifications? Okay. Love the factoring. To me, it's the fastest way, but it's not always. The issue is that it always doesn't work, okay? Because not every quadratic is factorable. Okay? When solving by factoring, after we factor that quadratic equation, it is mathematically legal to set each factor to 0 because of the zero product property. The zero product property says that when we have two factors multiplied to be 0, then one or possibly both of those factors must be 0. So back here in this blue step right here, we said, oh, we can go from blue to purple because of the zero product property. That's what that's saying. Okay? The zero product property is saying, hey, that's how we're going to solve things. We're going to set things equal to 0 because when they multiply together to be 0, one of them or both of them have to be 0. Okay? Thumbs up for keep going. Oops, there. Now my thumb is in there. Okay? All right? Solving by completing the square. This one, I don't know if you guys necessarily had as much exposure last year, what with the whole not being in school for fourth quarter aspect of it. So when we're solving by completing the square, the first thing that we have to do is I like to get all of my x variables onto one side and all of my numbers onto the other side. So I would first make this one be x squared minus 4x plus 11 equals 2x minus 10. Okay, so I'm first going to distribute this 2 into there. Okay. And now what I'm going to do is now I am going to subtract 2x from both sides, and I'm going to subtract 11 from both sides. Because what that does now is that gives me x squared minus 6x on this side. I'm going to leave this gap where the 11 was, and that's also going to give me negative 21. Okay? So that's how I separate my things. I leave this gap open here. I have all of my variables on one side. I have my numbers on the other side. Some teachers will have everything on one side and go from there. Me, I like it spaced out a little bit more. I'm a little crazy like that. Okay? Now, what we do is we hopefully can hit the extend the page. Okay? Now what we do is we look at this number here. This number right there is our B value. And our B value in this case is negative 6. Then we're going to divide that by 2. Negative 6 divided by 2 is negative 3. And then we are going to square that. Negative 3 squared is 9. This gap here gets filled with that last squared part. Okay? So that part goes in there and fills that gap. But now I've created an unbalanced equation. So in order to rebalance the equation, I'm going to have to add 9 to the right side also. Okay. With that being said, now on the left side, this is a perfect square trinomial, and it actually is x minus 3 quantity squared. If you need to realize that, or one thing that you might notice, I should say, is that that minus 3 comes from right here, that b divided by 2. And that's one of the cool things about doing it in this way, is that this number right here shows up as our b over 2. And we say that that is equal to, well, negative 21 plus 9 is negative 12. Okay. What you've done now is you have completed the square on that quadratic. Now to solve it from here, you are going to take the square root of the left side and the square root of the right side. One thing that I will tell you is don't forget, ooh, she's lagging today, the plus or minus. Because when we're taking the square root and we're solving, okay, we need to add the plus or minus to any number that we are square rooting. Okay. Left side just becomes x minus 3. Right side now becomes the square root of negative 12. Not a big fan of it. Okay? So 1, we can have the square root of negative 1. But 12 is also 4 times 3. So that's the square root of 4 times the square root of 3. So I would write this as 2, forgot something. I even just forgot it. Plus or minus 2i times the square root of 3. Q from there, I from there. Okay? Then to finish off our solve, we simply add 3 to both sides. So our two answers would be 3 plus or minus 2i times the square root of 3. An imaginary solution. Questions, comments, concerns, clarifications? Seeing none, let's go on to our next one. Our next one is using the quadratic formula. Couple of things when you're using the quadratic formula. First off, you've got to have it equal to 0. Okay? equation's got to be equal to 0, and preferably in standard form, ax squared plus bx plus c. Okay? And then lastly, the actual quadratic formula is x equals opposite of b plus minus square root of b squared minus 4ac all over 2a. One of those mathematical type things that you should just know. Okay. So then, this becomes x equals, so this is my a, this is my b, and this is my c. The opposite of negative 6, I'm going to write it out total longhand here for you, is going to be that plus minus big square root negative 6 squared minus 4 times a, which is 3, times c, which is negative 5, all over 2 times 3. Okay. Maths now is fun, so let's go here. Opposite of negative 6 is 6, plus minus negative 6 squared is 36. 4 times 3 is 12. 12 times negative 5 is negative 60. All over 6. $36 minus negative 60 is 96. Oh, what perfect squares go into 96? 16 does, right? Is that 6 times? Yep. Yep. So this then would be 6 plus minus, square root of 16 is 4, square root of 6 is the square root of 6, all over 6. If you had Kruger last year, Kruger likes to call it the bunny ears. For reducing, 6, 4, and 6 all have a common factor of 2. Oops, I missed it. On there. There we go. So then this would be, my final answer here would be x equals 6 divided by 2 is 3, plus minus 2, square root of 6. That square root of 6 is protected by the square root, or the 6 I should say. Inside the square root is protected by the square root, so it can't be reduced, and then all of that is over 3. Okay? Good times. We have some recommended problems for this type of solving, and these are also posted in all of P5 is graphing and solving like what we just did today, but these would just be the solving type ones. The rest of the P5 homework that is posted on its learning would include the graphing too. So there's that. That's all I got for you today. If you have any questions, by all means, feel free to stick around in the Google Meet. If not, have yourselves a great, grand, and wonderful, sunny-filled Tuesday. We'll see you later.